Jeremy? I don't know if I met Jeremy, but anyway, he's from Glasgow, but he does speak standard English. Sorry. And here's something you probably don't know, a random fact about Scotland. I do have Scottish heritage myself. If you get to the website of the Scottish Parliament, you'll see that actually there's 3 languages. Not 2, 3. They list Scottish Standard English, and that's Scottish Standard English. They list the Gaelic, and there's another language which is Ullans. No, it's not, it's Lowlands, or Lowland Scots, because the Highland Scots speak Gaelic, but the Lowland Scots speak something which is not Scottish Standard English, but it's, yeah. If you want to read it, go to the Scottish Parliament website. That's quite an esoteric language, which is the link. Did you see that coming? Which is actually the link.
Thank you. On the screen is the source code. This program isn't syntax highlighted, but I can show you it's there, look. The lexemes for this programming language, the programming language is white space, and the lexemes are 3 characters which are effectively invisible. We have tabs and spaces and new line characters. And these lexemes can be grouped together to form effectively opcodes in a stack-based programming language. White space was invented, amongst others, by Edwin Brady, who went on to develop Idris, the well-known programming language. This is a program. It's in the style of the artist Piet Mondrian, but this language can't be called Mondrian because that's a serious programming language. So this programming language is called Piet. And in this programming language, you have it's not a program counter, it's a direction pointer. The direction pointer starts at the top left and is pointing horizontally right. And the direction pointer moves, and every time it traverses a colour boundary, it subtracts those 2 colours and looks up that value in a lookup table of opcodes to again give you a stack-based instruction. And these instructions can change the direction pointer so it can move 90 degrees in any direction, and also to compute values on this stack. It's a beautiful program, don't you think? Thank you. This is Hello World, actually. Here is another program, this time written in the Shakespeare programming language. Here, variables are characters in our Shakespearean play. Well, actually, a character is a stack of values, but we'll just have single element values here. And control flow goes through the acts and the scenes, and you can repeat scenes and so on. And values are, well, +1 is a complementary noun. -1 is a derogatory noun. And then you multiply nouns by prefixing them with adjectives. I shall demonstrate with my Shakespeare REPL here. So here's Romeo and Juliet. And for instance, Romeo might say to Juliet, "Thou art a rose." And this will assign the value 1 to Juliet. But if Romeo were to have said, "Thou art a red rose," that would actually be 1 times 2 times 2, which gives Juliet the value 4. And you can do computational things. Thou art the cube of a red rose. Juliet is now 64. And then Juliet will reply to Romeo. Now, you see why it's a dialogue between 2 people, because you only say "thou art," you see, so that's the assignment, so you have to know who you're talking to. So only two variables are in scope at once here in this dialogue. Juliet's going to say, "Thou art the sum of myself," she's 64, and I'm going to have another positive noun here, a plum, right? Romeo's set to 65. Now, watch this, watch this. Juliet now says to Romeo, speak thy mind. And Juliet is going to output, oh, sorry, come back. Juliet is going to output character A, which is 65 as an ASCII value, but never mind. If Juliet had instead said, now let me get this right, I think if Juliet had said, open thy heart, then instead the numerical value would have been printed. So you see here that this language looks like the language of Shakespeare, Elizabethan English, and looks like a dramatic passage, but actually, really, it's just manipulating computation in a way with which we are very familiar. Do you know, Shakespeare was one of 50 languages featured in Dick Gabriel's and Guy Steele's 50 in 50 Programming Languages Review a few years ago, which some of you may have seen. So they certainly took it seriously. And that is what I want to plead for us to do today. Let's take esoteric programming language seriously. You have been laughing at white space and Piet and Shakespeare, but I don't want you to laugh. I want you to take these things seriously, or at least think about how they might have serious implications for us as programmers and for our understanding of what programs are and what programming entails. Here's Alan Perlis, and you may have seen his beautiful collection of epigrams. And one of his most famous epigrams is this: a language that doesn't affect the way you think about programming is not worth knowing. Somehow, a programming language shapes us and influences our thinking. Really, Perlis has specialized to the domain of programming, the more general Sapir-Whorf hypothesis, which may have been debunked in general linguistics, but let's just go with it for now. The structure of a language determines a native speaker's perception and categorization of experience. How you talk somehow determines, or at least influences, how you think. And we're going to contend that that's true for programming languages today. So this paper is available on arXiv, and this essay is also available in the proceedings. And I would encourage you, if you haven't done so, please to read it and have a think about it. Oh, here's my copy here. Good. Right. I think, here's an interesting observation. Esoteric programming languages are surprisingly popular in computer science. So I've done a few versions of this talk, and one of the things I did at the start of previous iterations of this talk is say, put your hands up if you've written a program in one of these weird programming languages. Do it, please. Good, okay, and as in previous talks, at least half the audience puts their hand up. That's very interesting. Okay, right, try this one. Put your hand up if you have written a programming language interpreter or compiler for an esoteric programming language. Oh, excellent, excellent, good, okay. And put up your hand if you have invented your own esoteric programming language. Oh, well done. That's a larger proportion than in any of my previous talks, so I am amongst friends. Good, excellent. Now, here's a thing. Somehow, computer scientists harbour a sense of shame. They're slightly embarrassed to admit in polite company that they have developed esoteric programs, or indeed esoteric programming languages. And I want us to dispel that sense of shame today. I want us to be proud about our esoteric language knowledge and ability. Right, just some definitions at this introductory stage. What does esoteric mean? That's the first thing to think about. And we could consult the Oxford English Dictionary and see that somehow it's to do with philosophy, and it's relating to an inner circle of initiates, people who are advanced in some school of knowledge or understanding, disciples of some strange teaching that is secretive and mysterious. This is esotericism. What is a programming language? We are in more familiar territory here. So I'm going to claim a programming language as a systemized notation for precise expression of intended computational behavior. This is what the ACM Encyclopedia says about programming languages. They're both tools for directing the operation of a computer and tools for organizing and expressing solutions to problems. So I suppose one might be for algorithmic intent and the other might be for computational execution. A programming language here. So if we put these things together, what is an esoteric programming language? And this is the definition from the, I suppose, homepage for many esoteric languages, esolangs.org. It says, an esoteric programming language is a programming language designed to experiment with weird ideas, to be hard to program in, or as a joke, rather than for practical use. The bold-facing is mine. So another quick audience poll. Right. So for this one, you vote interactively. 0, stick your hand up with no fingers. 1, 2, 3, 4, or 5. So, what do you think, dear audience? Esoteric languages are a significant research area that should be investigated. So, stick your hand up with as many fingers as you think appropriate. Ooh, this is interesting. Good, good. And you can abstain by not sticking your hand up. Oh, really? Dear programme chair, stick your hand up, please. But there we are. Thank you. Well done. Good. Okay, excellent. Good. So thank you. That's very helpful. Good. So I've got a sense of where we are here. That's good. So I'm going to move into the body of the presentation here and visit the archetypal esoteric programming language, which is called Intercal. So this was invented in the early 1970s by a couple of computer science students at Princeton University, and really it was a parody of the verbose and unwieldy imperative languages of the day. Think Fortran or COBOL or similar languages. Instead of the then universal go-to statement, there was a come-from statement. So you encountered a label, and then you went to the place where you should come from when you see that label. So effectively, it's kind of the reverse of the control flow edge for the go-to. Imperative statements may be prefixed with the modifier please. But if you say please all the time, the compiler tells you you're fawning too much and, you know, you're kind of a bit woolly, a bit weak. So you shouldn't say please too much. But if you never say please at all, it tells you off for being impolite. You should roughly say please between half and 2/3 of the time, I think, generally. Like Perl, variables are prefixed as to whether they are scalars or arrays, or I think this colon here indicates an array, and this is an assignment here. The struck through C symbol, the cent here, is a bitwise interleaving of these two constant values. That's 0 and that's 256. That's fairly normal. So you kind of interleave those bits together. Not very interesting because only one bit to set there, but you could imagine more interesting ones. And when you get to the end of the program, you denote the end of the program not by returning 0 from main, but instead by saying, please give up. And that's the end of the execution. So this was quite a joke of a programming language, but it was accompanied with a real implementation, a compiler that actually ran on their hardware in Princeton, and also a fairly extensive manual. So this was a well-documented programming language. Bratishenko coins the phrase techno-masochism to describe Intercal philosophy. The idea is that programmers somehow experience pleasure from the pain of writing in this very difficult programming language. And one person who was techno-masochistic was Donald Knuth himself, because he records writing a program in Intercal, and he documents this in Selected Papers on Fun and Games, volume 6 or 7, I think. If you like the look of Intercal, thanks to Eric Raymond, there is a C language implementation of the compiler and the runtime, and you can just apt install it on Ubuntu or brew install it on your MacBook, although I think it only works on legacy Intel Macs and not on ARM Macs, which is very sad. The compiler is called IC, And it comes with even more mysterious error messages than, say, GHC or other compilers. So here I've got a syntax error on line 1. No skeleton in my closet, woe is me. Correct source and resubmit. I think that's a deliberate typo. So claiming that Intercal is the archetypal esolang because it's kind of defining the genre here with syntactic absurdity and this satirical stance towards conventional programming language design. So what I'm going to do next is somehow categorize the entire field of esolangs into 3 broad groups. Now, these divisions aren't necessarily disjoint, so there might be some overlap between them. But I'm going to claim that the 3 types of esolangs that we see at large today are those which have pseudo-natural language syntax, those which have non-textual syntax, and those which have, let me say, an unconventional computational model. And you can see immediately there will be some overlap between these because the first 2 relate to syntax and the third relates to the underlying computation. We've looked at the Shakespeare language already and seen how Elizabethan theatrical script can be interpreted as programs, and there are other similar textual esoteric languages. So 1980s rock lyrics can be interpreted as code in the rockstar language. Recipes can be interpreted as programs in the chef programming language. And indeed, it's possible to write a program that can be executed both in your oven and on your computer. And in one case, it makes a delicious chocolate cake, and in the other case, it says something rude to you. But that's by the by. And also there's lol code, which is some kind of internet meme chat thing. And here's some examples here. So this is an assignment statement. All these languages. Thou art a red rose. We saw that in Shakespeare. Rose is 1. Red multiplies it by 2. Let your love be 2 is apparently assigning the value 2 to the variable love here. 2 grams of chocolate, and this again, this is stack based here, assigns the value 2 to this chocolate stack here. I has an R, X R2 apparently is X : equals 2, and then you can print these things out, opening your heart, shouting your love. Serves 1, I'm not sure about that. That's in chef. And visible X, there we go. So these things, you read them and they look like nice songs or plays or recipes, but actually there is structure hidden in the implicit in the text that can be interpreted by one of these generally stack-based programming language interpreters. We've seen non-textual syntax as well, like the white space language and the Piet language, which you saw there with its graphical notation. There are other non-textual programs as well. Programs can be written as directory structures in file systems. Where's my friend Joel? He was, yes, good. So I wouldn't have classified your language in yesterday's Onward as esoteric, but there are certain esoteric languages that do things like that. Yes, so it's possible indeed. So here the syntax is written in extraordinary ways, and somehow the artifacts are unusual and the things that you wouldn't expect to be programs. Unconventional computation, I think the canonical example here is John Conway's Fractan programming language. There was a typo in the camera-ready copy. I called it Fractan, sorry, it's Fractran, like Fortran. And Fractran here, you have a program with an initial input n, which is an integer value, and then a fixed list of fractions, and you execute the program by multiplying the integer n by the first fraction, which will give you an integer answer, and then you replace n by the integer answer and go round again. First fraction, which gives you an integer answer with a multiplication, and so on. You carry on until there's no such fraction and the program terminates. And this program here computes a list of prime numbers. And this is in the original paper from Conway in 87, Open Problems in Communication and Computation. And this is available on the Springer website. Here's another peerless epigram. Beware of the Turing tar pit, in which everything is possible, but nothing of interest is easy. So you see, these languages could be, and often are, Turing complete, but to write an interesting program takes an awful lot of source code, because really the opcodes are so simple, and there's no standard library, and it's rather complex to do anything interesting indeed. Violetta Lenati, from a computer science education perspective, explains how programs can be viewed in 6 different ways. And these things pair up. So a program, for instance, is both a human-made artifact and yet also a tool that does something when executed. It's both an executable entity, you can run it, and also a notational artifact. You can just kind of look at it. It's something that's abstract, and yet somehow something that's physical and embodied. And she speaks about how, depending on the way you express your program, depends on whereabouts in each of these different dimensions it lies. I'm going to claim that esoteric programs are generally more notational than executable, more emphasizing human manufacture than tooling, and probably more abstract than physical, but that's debatable perhaps. The point is that artifacts themselves are programs. Now, of course, not every artifact is a program, so you can't take the real text of, say, Hamlet and feed it into the Shakespeare interpreter because it doesn't have the necessary structure. There are often more than 2 people on the stage, and they don't necessarily say nice complementary things to one another that could be interpreted as assignment statements. But it is the case that every Shakespeare program could be performed as a play in the Globe at the Royal Shakespeare Company and whatnot. Okay, so here is really the meat of my essay here. Why are we so attracted? What is the enduring, alluring appeal of esoteric languages to computer scientists? And I'm going to claim there are 5 reasons for this. First of all, a sense of fun or playfulness. Here's a quote again from Eric Raymond. "We hackers are a playful bunch. We'll hack anything, including language, if it looks like fun. Deep down, we like confusing people who are stuffier and less mentally agile than we are, especially when they're bosses. There's a little bit of the mad scientist in all hackers, ready to discombobulate the world and flip authority the finger, especially if we can do it with snazzy special effects." So somehow, inside each one of us is a sort of rebellious instinct. And that's expressed in our esoteric programming language usage, perhaps. Perlis puts it like this, and this is a quote not from his epigrams, but rather from the prologue to Structure and Interpretation of Computer Programs. He says, "I think it's extraordinarily important that we in computer science keep the fun in computing. When it started out, it was an awful lot of fun. I hope the field of computer science never loses its sense of fun." And I feel that esoteric programs are fun, and maybe your laughter and humorous engagement with the esoteric programs we've looked at so far indicate that fun, which perhaps you lose when you're grinding through a 10,000-line C# program, or whatever else you might do for your day job. This is more exciting somehow, isn't it? More fun. Here's the second reason. This second reason is nostalgia. Here's Scotland's first digital electronic computer, installed at the University of Glasgow in the late 1950s. There's the first software engineer, and there's the first professor of computing over there with a proprietorial hand on the RAM. Indeed, that is a mercury storage tube array that's kept at a very certain temperature. And, in those days, and maybe when you started programming decades ago perhaps, it was just more difficult than it is these days. Do you know what I mean? Kids nowadays with VS Code and Copilot and things like that. It's just so easy, isn't it? You know, when I were a lad, you know, when I used to fire up Emacs and, well, I still do actually, but, you know, as things were back in the day, it was much more difficult. And when you were tracking down those, you know, unexpected bit flips and things like that, it was much more complicated, wasn't it? And I feel, and maybe you feel this too, the thought to execution ratio in software development used to be much higher than it is these days. And I think people have been saying that since Alan Turing, basically. You know, execution's cheap, debugging is easy, and thinking, who needs that? Well, I think you do with esoteric programming languages. Generally, you know, you have to think very hard and maybe write things down on paper as you write your esoteric programs. So perhaps we are harking back to those days when we had flowcharts on the floor and when we, you know, printed out memory dumps and looked at things and thought very carefully about what was going on. I'll read you a bit from the essay. It's rude about Americans, but sorry. It's often the case that experienced developers enjoy wearing the hair shirt, citing Simon Peyton-Jones, which involves putting themselves through difficult experiences while developing supposedly more elegant code. This trend originated with Turing, who invented the notion of optimal coding, whereby he would situate instructions at precisely the best locations in memory to be executed with minimum delay in a rotary memory machine. The pilot ACE had circulating mercury delay lines to store instructions, whereas other early stored program electronic computers employed complex control circuitry to avoid needing to make these instruction placement calculations. Turing wanted to defer placement complexity to the programmer. Campbell Kelly records Turing's thinking about using hardware interlocks to avoid the need for optimal coding as being, quotes, much more in the American tradition of solving one's problem by means of equipment rather than by thought. So Turing's saying programming should be challenging. Who needs electronics to help us decide where to place things? You know, we can live with our pipeline bubbles and our, you know, optimal encoding of delay lines and so on. It's, you know, don't defer to the compiler, optimize by hand. Here is a third reason for the attraction of esoteric languages, and this is a sense of cultic initiation. Here are the Pythagoreans bowing down to the rising sun, and, you know, there was a sense that they belonged. They knew about numbers, and they were the people. And maybe we too have this sense of belonging. We have been initiated into the cult of esoteric programming languages. It's certainly the case for natural language as well as programming languages that language functions as a social bond. You know, if you speak Klingon, come and talk to me afterwards, and we'll have a nice little Star Trek huddle in the corner. There's a sense of cultural identity, perhaps, isn't there? And I think a discourse community can engender that sense of belonging, and that's true in esoteric languages as well. To the novice programmer, unfamiliar syntax and abstract concepts can feel confusing and discouraging. By contrast, experienced programmers embrace this complexity, finding enjoyment and stimulation in the challenge. Esoteric programming languages foster a sense of community, a cultic initiation, an inner circle of programmers, engaging with code not just as a practical tool, but as a source of amusement, aesthetic pleasure, and intellectual play. A key point in cults and esotericism is the idea of transmission. You know, there's a kind of mystical way of becoming a part of the community. Thank you. I might say, here's a tarball of my latest esoteric language. And you're not going to get a Visual Studio plugin for this language. And, you're not going to find a Dummy's Guide to Learning This Language in 24 Hours, or indeed a Coursera module on this language. It's much more difficult to get into it, perhaps. Cultic initiation. There's artistic value as well, isn't there? Brooks talks about the sheer joy of making beautiful things. And Donald Knuth, again, talks about the art of computer programming. There's the idea of a thing being beautiful and somehow aesthetically pleasing, isn't there? We could think about live coding, for instance, where the coding itself is a performance. And here in esoteric programming, the artifact itself is a beautiful work of art. But then there's pedagogic value. So, we teach people programming languages so that they can do computational thinking in some sense, but as they learn a new language in a reflective way, they somehow relate that back to programming languages they know already. And side by side, they compare how to do computation in these different languages, and that teaches them more, perhaps, about computational models and about computational thinking. There's the idea of appraising language characteristics, which we would want our students to do in a kind of manner of critical thinking, and they could be very critical about some of these esoteric languages. Most esoteric languages were written by computer science students. And I think it's nice to consider that a language that's small and self-contained could be written, in an evening by an amused second-year undergraduate, or perhaps as a coursework exercise, or something like that. Many students undertake coding competitions like the Advent of Code. Does anybody here do the Advent of Code? You get 24 problems in the first 24 days of December, and you solve them in a language of your choice, and many people choose to solve Advent of Code problems in esoteric languages. Just search for Advent of Code in BF, and you'll find lots of interesting implementations and Git repositories there. Why do people develop esoteric languages? I'm going to very quickly talk about 3 reasons why this might happen. One is the comedic value of the language. And, there is a bit of a joke to this, isn't there, really? The white space language was publicly announced on April Fool's Day in 2000 and something. And indeed, it was inspired by an April Fool from Jean Strustrup himself, who spoke about how a certain dialect of C++ could be written in this kind of white space notation. There's a sense of challenge as well, and I think that's important, isn't it? The idea of working within tight, self-imposed constraints, which I think is a skill that's valued by software developers and is very necessary in esoteric programming languages. The Malbolge language, for instance, is practically impossible to write programs in, and most programs in that language have been synthesized by some kind of search-based techniques. But it's good to sometimes write code with a straitjacket, and it kind of teaches you to work very efficiently and correctly. And then creativity. I think this is important, isn't it? The attraction of creating a programming language of one's own. Enjoying the luxury of a break from the bland, bloated, multi-paradigm languages with imperative roots that everybody else is using. Esoteric languages are probably designed for the pleasure of the language designer rather than the end-user programmer. But there is a creative urge, a juice in every one of us to say, that's my programming language. And it's much easier to do that with an esoteric language, perhaps, than a mainstream one that other people are going to use. Just quickly, related work. So, an interesting book was published just a month ago called 44 Esoteric Languages, The Art of Esoteric Code, and you must take this seriously because it was published by MIT Press. So, check it out. It costs 50 quid, but how many dollars is that? I don't know, $60, but that's an interesting book to have a look at. Some of his languages ask programmers to write code in the form of a prayer to Greek gods, or as a pattern of empty folders nested in some kind of file system. There are constructed natural languages as well. If you go to vulgarlang.com, you can create your own constructed language and specify the phonemes and the morphology of your language. Sometimes people joke around with other systems like chess, for instance. Chess 960 is where you randomize the back row of your chessboard, and there are 960 combinations as long as your bishops are on opposite coloured squares, and you can still castle effectively. So this is a way of perhaps looking at a very familiar thing in a slightly different way. And indeed, there are joked musical instruments, and perhaps you've seen some of these, and these can be used in serious ways, perhaps. And I just put this in as a nod to the previous talk. Look at this. I've developed a new programming language. Didn't a judge order you to stop doing that? High Court throughout the ruling. Back, suckers. I promise it's good this time. Normal code, good clean syntax, nothing weird. Except the only variable name is x. To refer to different variables, you have to write x in different fonts. There's XKCD's esoteric programming language. I will conclude, and I'm going to say we must take esoteric programming languages seriously. They challenge conventional thinking in terms of both programming language design and the nature of programming itself. As Perlis says, a language that doesn't affect the way you think about programming ain't worth knowing. Thank you very much.
Out of time, but there's half an hour until the break. I don't want to have questions from it, but yes, there is a bit of time for questions.
Yeah, I was going to bring up constructed languages, and then you brought them up. So I guess have you ever heard of Agma Schwarz, constructed a cursed conlang circus?
No.
Is basically like a bunch of linguists and all linguistic interested people like creating conlangs, which are designed to be cursed. And I think this is basically, so some of them do phonetics that are very cursed, but some of them are basically like, there's one which is essentially a hashing algorithm, and there's another one that's like from set theory. Like essentially it's just saying that you can use set theory in theory to talk about anything. So like, I guess, that might be something to look into.
Thank you. I will. Thanks. Yes, so constructed languages are interesting. I mean, from the days of Esperanto and things like that, people have reasons, and often laudable reasons, for constructing languages, and your reasons might not be quite so laudable, but we'll look into it. Yes, thank you.
Is the lambda calculus an esoteric programming language?
Good. So, I think I'm claiming languages are esoteric when we consider the motivation of the designer, and I don't think Alonzo Church was intending his language to be used in humorous ways.
I like that answer.
Yes.
But of course there are... Oh, go ahead, you for yourself.
Sorry, however, I think you could fall into the Turing tar pit trying to write an interesting program in lambda calculus.
Well, there are esolangs that are just combinator calculus but realized, and then those become esolangs when combinator calculus is researched. So what's the difference?
That's nice. Thank you. Yes.
I wonder if you know of any concepts that were introduced initially by esoteric languages that have entered the mainstream and influenced the field.
How nice. So often when I'm teaching Haskell to my students, I say, and here, look, list comprehensions are now available in other mainstream languages and things like that. Is that true for esoteric languages? Sadly, I'm not aware of anything, but I should think about that very carefully. Yes. Give me an example, James, please. Yes. Yes.
Thank you.
I think that's said with tongue in cheek, but yes, very nice. Thank you. Lovely point, Nick.
He got my question, but I do have an answer. I do have an answer to that, which is that, if I remember correctly, there is a commercial COBOL that had come from. Really? It exists. It's real. It's out there. I'll just say this. I think it's very funny. Obviously, Wittgenstein said, we could conceive of a language composed entirely of jokes. I don't think he could have foreseen that would literally happen in the form of programming languages. But yeah, I'm 99% certain the come from COBOL COBOL exists.
Oh, lovely. Okay, we'll check that out too. Thank you.
I have another answer to that question, which is I remember a programming language that was like, oh, usually the compiler parses your code and ignores the comments, and what if you had a language that parses your comments and ignores the code? And I think with modern Copilot tools, we're there. So.
Very good, very good. A truly literate program. Thank you. Thank you. Very nice. Good. Thank you.